Hello, my name is Robin Sehler. I'm a student from the University of Minnesota, working in the Department of Soil, Water, and Climate. And today I'm going to be sharing with you about the foundations of soil health. And the overview for my presentation today, to begin, we're going to be talking about the worst man-made ecological disaster in United States history, which was the Dust Bowl. And then we're going to talk about the foundational principles of soil health. And then I'm going to share a little bit of how we assess soil health, including an overview of the methods currently used, and then focusing in on the eddy covariance method, which I am also working with in my own research. And next, we'll talk about soil health and how that relates to human well-being. We'll specifically cover this concept known as hidden hunger, which is occurring around the world, as well as recent instances of heavy metal contamination in food, which is related to poor soil health. Next, we'll be talking about ways consumers can make choices to actually improve soil health initiatives. And then finally, we'll have a group reflection with several questions, so you guys have a chance to talk to each other. So section 1, the Dust Bowl. So beginning in 1930, there were a series of 3 major droughts. And in the Great Plains of the United States, and this led to massive erosion and the removal of the very valuable topsoil, which is really what crops rely on to be fertile. And so you had massive crop failures within 5 years from 1930 to 1935. It's estimated 750,000 farms were lost. You had massive migration, especially from Oklahoma to California, and those groups of farmers were called Okies. And there was massive unemployment, and then the jobs that were available, wages just went down because there was such a demand for them. So there was real economic instability, which contributed to the Great Depression and the collapse of US banks. So really an underlying problem was not only the droughts that were experienced in this part of the country, but it was the management, because what had happened was that the native prairie grass, which was deeply rooted and very good for the soil and its stability and structure, that grass was removed and replaced with wheat, which has shallower roots. And just with the lack of rain, the soil was not as sturdy. And with all the topsoil blowing away, that also led to health problems such as widespread pneumonia, because people were inhaling so much dust, and that led to deaths, especially for vulnerable populations such as children. And you'll just see here images of entire families packing up everything and leaving their old farms and traveling across multiple states just to search for work. Section 2, I'll get into the foundational principles of soil health. And there's 4 main principles that I'll cover. And this information is taken from some really well-organized fact sheets produced by the USDA. So the first principle being maximizing living roots in the soil. Secondly, minimizing disturbances to the soil. Thirdly, maximizing soil cover. And fourth, maximizing biodiversity. And we'll talk a little bit about each one. So just to give you a picture of soil health, so you have an image, these are examples of what healthy soil looks like. Healthy soil is an ecosystem just filled with life. So you see a lot of roots, you see the earthworms, there's fungi sometimes, there's a lot of life in the soil if it's healthy. And For the first principle of soil health, maximizing continuous living roots, um, the management techniques that are utilized to support this include crop rotation, um, using a cropping system called relay crops, planting perennial crops, and utilizing cover crops. And what that means basically, so crop rotation, for example, instead of just planting corn continuously for 10 years in a farm, crop rotation would be the opposite of alternating between planting corn and then planting something like soybean or alfalfa, because that soybean or alfalfa is going to fix its own nitrogen from the atmosphere and put it into the soil, which is going to just improve the soil health. So crop rotation is the idea of growing different crops in the same field so that you're maximizing the soil health. And relay cropping, it's a similar idea, but instead of just waiting for one crop to completely end, you're actually planting that crop. You're planting two crops at the same time. And then this third example here, perennial crops, that's as opposed to annual crops. And so an annual crop is like a type of plant, basically, like you have to replant it each year, whereas a perennial crop, you plant it once and it can stay living in the soil for years at a time. And the reason that's important to soil health is because then you don't have to till it and reseed it. Like basically you can keep roots in the ground, which is going to be really helpful for soil carbon and soil health. You're not disturbing the soil. You're going to get less erosion. You're going to have better water filtration into the soil because of those deep roots. Perennial crops, they're really cool because they actually have a different survival strategy than annual crops. And so because they're more geared towards lasting a long time, um, they can develop like much longer roots. And these roots are so significant and helpful in capturing carbon and locking it in the soil to help the soil be healthy. And then cover crops, I mean, it's kind of like what the name sounds like. You're keeping the soil covered with crops that are usually, they're not that cash crop, they're other minor crops, just to make sure that like the soil is not bare. You're not going to lose that soil to erosion. You're going to lock in water better. The structure of the soil is going to be healthier. And I always like to include examples of, well, for perennial crops, what you're seeing here, pictures of alfalfa. And they have those extremely long roots. It's one of the crops that I focused in on my research. And these roots can extend up to almost 50 feet deep. I should say down to 50 feet deep. And this picture on the left, you can see like the alfalfa right here and how long that is. These corn roots, like how short that is. And then I believe this is wheat here, somewhere in the middle. But if you think about, for example, the dairy industry, maybe 60 years ago, these cows were fed more of a mixed ration of their feed. And even in ancient times, like alfalfa was such like one of the most widespread sources of food around the world for cattle. But there's been so much subsidizing in more recent times of corn, especially within our country. And it can be a lot more economically feasible in the short term, at least, for farmers to grow corn. And so they'll end up, our what we feed to our cattle has shifted more to be corn-based, but that's not healthier for the environment, the soil health. And it's not necessarily healthier for human consumption either, because corn is more, from my understanding, is more of a sugar-based source of food, and alfalfa actually has protein. And another, pardon me, another principle of soil health is minimizing disturbance to the soil. So some management techniques would include like just conservation tillage, basically. So either not tilling the soil at all, only planting and spraying, or reduced tillage. So there might be a little bit of tillage, and you'll see in this diagram, it says cultivating, planting, cultivating. Whereas in conventional tillage, you're plowing, disking, cultivating, planting, and cultivating. It's just a lot more disturbance going into the soil. Thirdly, to maximize soil cover, certain management techniques used include mulching, again, reduce tillage, residue retention, which is just keeping as much of the plant, once it's harvested, at least keeping some of that plant biomass on the soil, because that's eventually going to return carbon into the soil. And then cover crops. So keeping the soil covered. And as you can see from this picture, there's advantages. Erosion control, weed reduction, nutrient retention, and building soil health. And finally, the fourth principle of soil health is maximizing biodiversity. So again, what's used is crop rotation, and then rotational grazing in terms of like livestock agriculture. So maybe cattle will graze in paddocks, or like kind of different, like a farmer will just create these different plots of their land so that the cattle are not just eating everything at once, but like they're systematically eating and then creating their manure, which is going to like provide nutrients back into the soil, and just doing that in a systematic way so that the overall soil health is optimized. And then using legumes in their rotation, and legumes, like for example, alfalfa is a type of legume, and as I mentioned before, they can fix their own nitrogen. So basically, I mean, these are smart plants, like they basically absorb nitrogen gas from the atmosphere, and like within the roots, like under the soil, they're able, just working with bacteria, they're able to convert that atmospheric nitrogen into nitrogen that's used for the soil as a fertilizer. So when you're planting legumes, like you don't need to, under normal conditions, you don't need to use nitrogen fertilizer. The farmer can save a lot of money. And maybe some of you are familiar with the process of creating industrial synthetic fertilizers called the Haber-Bosch process. Excuse me, which is highly fossil fuel intensive to create, like to go from ammonia and convert it to nitrogen as a fertilizer. So you're really saving the farmer money by using these legumes that produce their own fertilizer, and contributing less to greenhouse gas emissions by not needing to use fossil fuels to synthetically create these fertilizers. Excuse me. And then again, cover crops and livestock integration. Excuse me. Next we have section 3, the assessment of soil health, and like, how do we know? Like, how do we estimate that the soil is actually healthy, and like these management techniques are even doing anything? So I just wanted to include a quick visual here of like what carbon poor soil looks like versus carbon rich soil. But using more quantitative assessment techniques, it really depends on the scale. Like if you're trying to assess a farm, you're looking at the field scale, and some of the methods used are LIBS, or the laser induced breakdown spectroscopy, INS, which is inelastic neutron scattering, DRS, which is diffuse reflectance spectroscopy, and EC, which is eddy covariance. If you're looking at more like of an ecosystem scale, slightly larger, you could use that eddy covariance method again. You could use a life cycle analysis called an LCA, or back to that DRS, diffuse reflected spectroscopy. If you're looking at even broader scale, like a regional scale, you could utilize soil organic carbon models, SOC models, or if you're just doing a site by site, if you're just doing a site by site analysis, in a laboratory, you use dry combustion or wet digestion, which to be honest, I've never used that. I mean, that's often those laboratory site by site measurements are considered the gold standard of estimating soil carbon. But I mean, you could probably just kind of understand this is that if it's site by site, it's going to be a lot more expensive. I mean, just think about a 3D rectangular prism, and like point by point, you're trying to get all these measurements. So it's only representing a small point in that rectangular prism. So the scientific community uses just other methods to estimate soil carbon for the whole volume and at different scales. So I'm going to focus a little bit on the eddy covariance method. And so eddy covariance, it's really simple actually. The core concept is like, think of a bank account or a piggy bank. And that piggy bank is going to be your field. And the money is going to be the soil carbon. And so the eddy covariance method, what you can estimate is like the net balance of soil carbon. So you either have a net positive of soil carbon, where those agricultural management techniques that we talked about a little bit, like when you assess how much carbon there is in the soil, you're seeing that there's an increase in that soil carbon, or there's going to be the net loss of soil carbon. So over time, you can see that you're losing soil carbon, and that's significant for two reasons. For one, because as you're degrading your soil carbon content, which is really kind of represents the life in the soil, like over time, your crops just aren't, they might not have the same nutrient density. They might not even grow as well at all. And then also that carbon being lost is going to go into the atmosphere. And it's going to be a greenhouse gas. So that's going to contribute to climate change, really. And this diagram to the left, how soil stores carbon, we talked about that a little bit, but as far as like carbon being released back into the air, but above ground, you have plants absorbing carbon dioxide through photosynthesis. And then, the plant is going to grow and produce the carbon-rich organic matter. And the plant's going to decay, and then microorganisms in the soil are going to feed on that decaying plant material. And then the microorganisms are going to release that carbon into the soil. So a little more about the eddy covariance method. So eddies, like what we're referring to when we talk about eddies, we're just talking about these gusts of wind. So going back to like this visual of a rectangular prism that's representing a field, but really also it's representing the whole ecosystem of an agricultural field. And this image to the right is showing you an example of an alfalfa eddy covariance tower site. There's tall towers like what you see in the left image, and then there's short towers, what you see on the right. And so the sensors, they're measuring the wind gusts and the horizontal and vertical like shifts in those wind gusts. And through this method, you're able to deduce the change in carbon dioxide in this area, the location that represents this ecosystem, and really estimate eventually estimate in the soil if you're having a net positive or a net loss of carbon in the soil. So I just wanted to share a little bit about my research. One thing I'm hoping to do is really bridge two science agencies together, the US Department of Agriculture. So they're they're the ones doing a lot of research on the ground, of course, utilizing methods like eddy covariance, but also just taking site-based, like in situ soil carbon samples, but also working with NASA because they like they use radar, for example, the SMAP radar, soil moisture active passive radar, um, to develop soil carbon models. And of course, like if you're more into the modeling world and like are familiar with SMAP, you'll know that it's really like a coarse data set. And this L4C carbon product is really only designed currently to like estimate 8 major land covers. So it's not that helpful to agricultural users because agricultural users want to focus in on like specific crops to see, oh, how I'm managing the specific crop and how that's going to affect the soil carbon. So what I want to do, and I'm kind of begun talking to both organizations, is to calibrate the SMAP model so that it can more accurately estimate soil carbon cultivated from alfalfa. And so I would have to gather a lot of data from eddy covariance towers specifically for alfalfa, alfalfa to do that. In section 4 is we're going to talk about soil health and human well-being. So unfortunately, this phenomenon known as hidden hunger is happening around the world. So as you have soil depletion just rapidly increasing, researchers and the references down here are stating that 1 in 2 preschool age children around the world have a micronutrient deficiency, and 2 in 3 women of reproductive age have a deficiency in micronutrients. So the more the more the more we can protect our soil, the more we can protect human health. Additionally, one of the main issues with soil health and how that links to human nutrition and human just physical well-being. What I would say, one example is contamination, especially if you're a parent, you'll know this. Like I had a baby 3 years ago. And when she was born, like well, within that first year of trying to get her baby food, just seeing that in the news, like so many of these common baby food companies were being recalled due to heavy metal contamination. And you'll see like there's research to the left here that shows that that can be linked to autism. And then to the right here, you'll see like legal organizations kind of trying to educate the public and potential clients about how this is happening. And they're pointing out agricultural practices like fertilizers and pesticides, synthetic ones. Their trace amounts of heavy metals can build up in the soil. So, we talked about synthetic fertilizer versus like a natural fertilizer from a perennial such as, or legume, like such as alfalfa. And like you can start to see the ramifications of these management techniques for soil health and then human health. And especially when you're dealing with like a little baby whose organs are small, like that's a considered a very vulnerable population to soil health. And, there's just even further research about how it impacts a person to have this exposure to heavy metals and to have neurological challenges and how that impacts their life quality. And there's tons of, I suppose, like sociological research about that. So really, we're not talking about like agriculture in its own silo. Like it really does relate to some like our everyday lives. And here's just a chart, a congressional investigation, which really just highlights how high the contamination was. Like, for example, okay, let's see. Here, the recommended adult limit for arsenic, 10 parts per billion. But in Gerber baby food, they found 90 parts per billion and 100 and well, up to 309, no, up to 913 parts per billion of arsenic in beech nut baby food, when an adult is not supposed to have more than 10 parts per billion. And how is this going to affect a little baby whose brain is still developing? Like it's pretty horrific. So with that said, though, it's not um consumers, we have quite a bit of agency in terms of the products we choose to buy. There's a lot of great products out there, especially locally. Well, I'm saying locally because I'm from Minnesota here in the Twin Cities, but like if you have access to a co-op, but some of these regenerative agriculture companies will mail you their products, but there's also other questions about like buying things locally and if you're really concerned about like the environmental impact of like your food choices. So I guess that's more of a gray area that you'd have to kind of weigh out with just like details of where you live and like how far away the food is coming from. But one local brand for us in the Twin Cities is Thousand Hills beef. And like this is from their website. I love it. Like they specifically talk about carbon farming and like what they do as a company to try to preserve soil health. They don't till, they compost, they use organic mulch to help reduce emissions, including wood chips and crop residue. They use cover crops to provide carbon in the soil during the cold months. And they rotate their livestock. So they all have their grazing herds through using paddocks instead of just like having them graze the entire pasture so that um, it just has time to build up the soil health from the manure. And then you have like this other company called Perennial Pantry, which offers a lot of different foods made from perennials, but one I wanted to highlight, we talk a lot about at the University of Minnesota is Kernza. And so, again, it's as a perennial, like you get to plant it and it's going to stay in there for several years. You don't have to till it. Like it's going to do better. It's going to be better guarded against erosion, most likely. Like it's going to retain water better, most likely. And you can just take a look at like the different tasty foods that you can make using this flour. So lastly, our group reflection wanted to give you some time to just talk about 3 major questions together. And our group facilitators can just like stop this and pause it as like whenever you see fit. But first, what are some of your favorite meals to eat? What are some of your favorite memories or traditions surrounding food? Second, can you think of any ingredients or brands to utilize in order to make your favorite meals more sustainable for soil health? And if you don't have any idea, like feel free to research brands as we're talking if you need to. But some examples of substitutions would be eggs laid by grass-fed chickens, milk or butter sourced from grass-fed cows, flour made from perennial plants, and grass-fed beef. And question 3, what is a soil health supporting recipe you would be interested in trying to prepare, or at least trying to eat? And please share with the group a picture of the food and a little summary of the recipe. And just feel free to find online recipes from any site, but here are recipes from those 2 featured companies that I just talked about. And that's it, everybody. I really thank you so much. I I appreciate you taking the time to listen to my presentation. If you have any questions, please don't hesitate to email me at sehle001@umn.edu.